Okay, so today we will be working on homework 11. This homework has to do with flip-flops and timing diagrams. So let's start with the first one. So problem 1 says the counter below changes states on the rising edge of the clock. Fill in the table below, show the count sequence of this counter starting at 0, 0, 0. So for this problem, all we're going to do is fill in these boxes with 3 bits, and once we get to the bottom, we are done. So the first thing we need to do is start with our beginning code, and they gave us 0, 0, 0. So for Q2, I'm going to put a 0 right there. Q1 gets a 0, and Q0 also gets a 0. So not too tricky so far. And now all we're going to do is continue, or we're going to draw these zeros as they wrap around to different locations, just so we can better work with these gates. So this bottom 0 carries over to there, and it carries up to there. The middle 0, and it carries to there. This middle 0 also carries to there, and this top 0 carries over to there. Oh, and I missed one over here. This one carries up to there. So now that we have those drawn in, we can do the next step. I'll do it in yellow. We can fill in the rest of the gates. Actually, let's do this in green. We'll start on the bottom. So the 0 becomes a 1. And as you know, for an XOR gate, if both of the inputs are the same, we're going to get a 0 out. And for the top one, we get a 0 here. And because that's an AND gate, 2 zeros into an AND gate gives a 0. And 2 zeros into the XOR gate gives us a 0. So this is our beginning setup. We started with 0, 0, 0, and we worked our way all the way back around to this column, which is 0, 0, 1. So that means when the clock goes high, all of these numbers will pass to the other side, and we can fill in our table with the second set, 0, 0, 1. Not super hard so far. So now that we have that, what we need to do is replace this 0 at the bottom. Now that it became a 1, let's erase that and replace it with a 1. So now let's go in and change all of the places where that has become different. So it will change here, here, and here. And so that means that this becomes a 0, and this one will become a 1, and in the top two 0, or a 1 and a 0 into an AND gate will still give us a 0, so nothing changes on the top. So then on the second clock, these will all pass over again to the other side, and our third box will get 0, 1, 0. So let's do one more just to make sure that you guys have it down. I'm going to erase everything that I scratched out, and we know that now we have 0, 1, 0, so let's fill those in. 0, 1, 0. So this 0 down here will replace that one, and this one, and that one, and this one will become a 1, and so down here on the bottom, this will become a 1, this one will stay a 1, so that's fine, and everything on the top is still zeros, and so we can get our third box, which will be 0, 1, 1. So all you have to do is fill in the rest of the table with all of those steps, and if you notice a pattern, good for you, you can fill it in from there. But if you don't notice a pattern, you can just keep working it out. It's not super hard, it takes a little bit of time, but not horrible. Okay, so let's move on to question 2. So for this one, this one's a little bit trickier, so let's talk about what's going on here. So let's see, when we have two flip-flops connected together, DQ, Q. When they're cascaded like this and they're connected to the same clock, what happens is you have something that is waiting to go into the box. So let's call it A, and let's say that B is already inside of this box and C is inside of that box. So when the clock goes high, this is going to go into this box. So A will now be in this box, but the B that was here will go into this box, and C will get thrown away. And so if you had more than 2 flip-flops, you could hold 3 things or 4 things or 100 things if you had 100 flip-flops connected together. And so in this case, we only have 2, but the main thing is when the clock goes high, this A does not pass all the way down the line, but it only moves 1 flip-flop at a time. So when we're doing this problem, lucky for us, it tells us the initial values. It says, assume both flip-flops are initially reset to 0. Complete the timing diagram for the circuit. So on here, let's set this to 0. So we have a 0 here and a 0 here. And so when I draw the 0 right outside the box, that means it's connected to Q. But you could draw it inside the box if you want to, as long as you know that these are the same. I prefer doing it outside of the box, just because now it's attached to the wire or next to the wire, and it just helps me see what's going on. So this 0 will carry across and be a 0 up there, and this 0 goes through the NOT gate and becomes a 1 right here. And we know that into this AND gate we have a 0 and a 1, so we will have a 0 as our output. And we can see that this is our initial condition, 0, and in our timing diagram, they say, or they give us 0 is our initial condition for R, which is good. That just means that it's set up correctly. So let's talk about what this timing diagram means. So here we see this clock. So this is the clock that controls the flip-flops. And these are called rising edge flip-flops, and that is indicated by this little triangle on the bottom. And so all that means is that Q becomes D on the rising edge of the clock cycle. And so that means at this point, this point, this point, and so on, that's when the register, or Q, that's when Q can change. If it were a falling edge flip-flop, the little triangle wouldn't be there, and all that would mean is that on the falling edges, that's when it would change. But for the most part, you're going to use rising edge flip-flops. So let's erase some of that. So like I mentioned, the only time that the registers are another word for flip-flops, by the way. The only time that these registers or flip-flops can change is on the rising edge. So what I'm going to do, and I recommend that you do this when you're working on similar problems, is I'm going to draw vertical lines on the rising edge of all of these. So this will just help me keep a frame of reference for when things can change. So if I am drawing my diagram and I draw something like this, what we'll notice is that change didn't happen on one of my yellow lines. And so that's wrong. It has to happen only on those yellow lines, because the only time anything can change is on the rising edge of the clock. And so this just helps me avoid mistakes. So, and then what I'm going to do is go through and just label these 0, 1, 1, 0, 1, 0, just so I remember what those values are at those certain times. So what we do is, let's do this in red. So our first input is at the first clock edge, so we're looking at this. Our first input is this 0. So we're going to put a 0 as our input. And on that rising edge, like I mentioned over here, this 0 will move over to this spot, and this 0 will move over to that spot. And so what I'll do is I'll scratch these out and replace them with zeros, which doesn't really mean anything, but they both slid over one spot. Since they were already zeros, nothing really changes, and so our output will still be 0. So we know that after the first clock cycle, meaning after this point, our output R is still 0. So what we can do is draw a 0 up until the next yellow line, because we know that the output R will be the same all the way until we hit this yellow line. Okay, so now at the next clock cycle, let me erase some of this stuff. Let's erase the values that were gone. So at the next clock cycle, now we're working on this one. Our input is a 1. So we get rid of the 0 and we replace it with a 1. So now we're going to pass a 1 over to here and a 0 over to there. So this one, we'll scratch it out and leave it a 0, just practice. And we'll scratch this one out and write a 1. So now this one will wrap around all the way to over here. We can scratch out that 0, replace it with a 1. And what we'll notice is we have 2 1s going into our AND gate. And so that means that our output is going to be a 1. So we come down here to our output R and we draw a sloped line going upwards. The reason we slope it is because we assume that nothing can change instantaneously, and then from there we draw a flat line all the way till the next clock edge because we know the output will be the same until we get to the next clock edge. Okay, so let's keep going. Let's erase a bunch of this stuff. Okay, so that's where we are right now. And what we'll notice is, and let's remove those. Now we're on the third clock edge, and our input is still 1, so we still have a 1 up here. And so now, when the clock goes high, this 1 goes over to there, and this 1 will go over to there. And so this 1 will become a 1, and this 0 will become a 1. And so all that will change is this 1 will become a 0, and now our inputs to our AND gate are a 1 and a 0, and so our output R goes back to 0. So we go back down to our output R, we draw a sloping line downward, and then we continue that line flat along the bottom until we hit the next yellow line. So I'll let you go in and finish the rest of it, and then to finish the question, it says, can you tell what this does? And so for that, you don't need to know anything specific for this answer, but I want you to think about this question. When this goes high, so when S goes high for 2 cycles, R went high for 1 cycle. And then when S went high for 1 cycle, R again should go high for only 1 cycle. So in theory, we can assume that if S went high for, let's say, 50 cycles, then R would still go high for 1 cycle. So what you'll notice is no matter how long S goes high, R will only go high for 1 cycle. And so see if you can come up with something for that. We're not looking for anything super specific, but try and explain that in your own words. And then the last thing on this question, for any of you that are wondering, I'll do this in green. At the very beginning of this problem, there is this X right here. That is not super important to the question. It's just giving you a frame of reference for how R is labeled, or the initial condition of R. If they had drawn it like this, then you would know R starts out as a 1, but because they draw it like this, you know R starts out as a 0, and the X is just showing you that at this point, R can change. It doesn't have to, but it could change. But other than that, it's not super important, and you won't have to make them in your own drawings, but that's the use of that. Well, if you have any questions, you can email any of the TAs.